All right. Okay. We're back. We're back to a more fluid simulation and stuff. Now, before I go last time, right? We talked about improving the collision, but right now I'm also working on the improved renderer. So I just did some a little bit more, right? For the preview for the split system, and now I want to be able to color in the color into the fluid directly based on its velocity. I think it might be interesting to do, might give you an interesting result. So here, the last time we modify the renderer, the flip renderer to render out the pure white, right? The alpha, right? The pure, well, what? The pure white circle with faded alpha instead of just white to black, because it's now allow us to blend in custom color, set this C white to any color we want, and it should keep that new color. Like if I say red, now it should be red. Oh no, oh no, it's not red, it's just black. All right. If opacity higher than that, you get the fluid RGB. Alpha opacity is 1, so that's not right. Let's just say oh, there's also a shader here. Oh, maybe it's this shader. Yep. Oh, it is this shader. Okay. This one is convert. Apply power to the grayscale and then get the grayscale powered by 5 and then convert it to black and white. Interesting. Let's just use alpha opacity instead. Right, and we can just say A, and this one is color RGB. So probably just modify the alpha curve to make it look more natural. Now we get the completely red. Now we might want to increase the default particle expansion a little bit here. Let's say 16, 20. Yeah, let's just make it twice as big. And now we can fill in the color. That's really nice. Then in the rendering effect for processing, maybe in effect you can add gradient. You can say color over velocity. It's kind of laggy now. That's kind of what happened when I opened the project in GameMaker Studio, GameMaker for too long. It started to get laggy. I might have to refresh my computer. New gradient object. of white, right? Yep. Put that after, before the effect color over velocity. 11, right? 11. So we have color, CVL. Now I think we can also get the velocity here as well. Okay, this is getting really bad. It's really laggy now. No. Okay. Let's refresh. Get the speed x, speed y, and then can get velocity. Just be this, but and then we need to have a velocity map, right? To map the velocity values into 0 and 1, between 0 to 1. So we say velocity map float 0, 1 range. VLR velocity range. Get the velocity here, and then we're gonna have velocity position in map velocity. Let's say v map would be velocity minus VLR 0. Let's just pre-calculate that. Let's say, where should it be? Use right here. V map range equal VLR 1 minus VLR 0. I see the color here would equal CVL evaluate at V map. Like that. Let's see. Which countries are you from? I'm sorry I didn't read chat very often. I'm from Thailand. Yeah, and thank you. I'm glad you enjoy Pixel Composer. Yeah, I'm not gonna check back at the chat from time to time because I don't want to be too distracted. But yeah, I'm glad you do. Whoop, particle velocity not set. Particle velocity. I think I may have deleted. That's weird. Velocity, particle velocity, particle velocity. Yeah. Just create new fluid and it draw in normally. That's cool. Then we add color velocity properties, some gradient. And it's still white. That means it's too high, right? 0 to interesting. Okay, let's just print. Let's just print the velocity out. No, actually it's just from 1 to 10. 1 to 10, right? So maybe because we used additive mode, that's why it become white very quick. So we can do equal clamp 0 to 1. And then we do go over by 5. Alright, just put it in some curve, like map it in power by 5 curve. So okay, it's way more clear now. The faster the particle move, the slow particle gonna be black color and the faster particle gonna be white, and you can change it using gradient. I mean, that's pretty cool. Yeah, I think that's pretty cool. That's a cool effect, right? Probably. Yeah, I like that. Obviously you don't have to use it, you can just set the gradient to white and it will just be a normal shape, normal color you can change later. Flip render, add color over velocity properties. Add that. Okay. What else? Collision. Okay. Talk about it last in this morning. Simulation flip domain apply force. Is the obstacle was supposed to push the particle away, right? But it does the opposite somehow. It pull pull the particle, it pull the fluid into itself. So that's kind of weird. Say flip fluid, spawner, collider. So if the fluid flow toward the collider, it will kinda avoid the collider properly, right? Kinda, because it's just kind of like phase in to the collider a little bit there. That's kind of weird. Oh no, what's going on now? It freeze. Oh no, oh no, oh no. Resizing the animation mid animation. Yeah, that's a bad idea, I think. In the if not is playing, because now it's freeze. Oh. We have normal fluid flow down normally. Okay, cool. Then we have collider here. It's kind of avoided, but it also fades into it a little bit, which is fine. But then if we have the collider move, that's okay. Well, take a look at the fluid simulation part. Set obstacle circle. What it does is we just define obstacle object from list of all obstacle in domain. We set the properties, the x, y, the radius, all of this stuff. We calculate the velocity of the obstacle by comparing it to the previous frames, right? Vx, vy, yep. Then we set the velocity of the part, or we set the velocity of the obstacle into the grid. Right. So it doesn't affect the particle itself. Yeah, it doesn't impact the particle speed itself, but it impacts the vector field, the velocity field in the back. But then there's this part that can calculate obstacle velocity x, obstacle velocity y, and when you handle particle collision, here you check for each particle. You then why is this one outside? Why shouldn't this be in here? Right, because it's only used in their own scopes anyway. Right, but anyway, you check each particle, check if it collides with the obstacle or not. If it does, it calculates. It applies the velocity of the obstacle to the velocity of the obstacle of the particle. So this is the collision part. Interesting. So what if we just force move the particle completely, right? We do particle pose I2 would equal wait what obstacle x plus dx multiplied by or divided by square root 2 obstacle x have to move outside of the obstacle, so it has to be obstacle x if d2 less than minimum distance 2. Actually no, it has to be obstacle x has to plus equal or minus equal the current position and the obstacle position, so it has to be plus equal dx multiplied by two over this, right? No, it has to multiply by minimum distance divided by distance, right? The object particle minimum distance to here is actually a minimum distance times minimum distance, which is the radius plus the current object radius, so it's not square. No, it is square. Not square. But it has to divide by square root of this. This will not be efficient. Or square root is quite slow. The same thing with dy. Right? Let me see. Let me think for a sec here. So we have obstacle with radius of r of big R, particle with the radius of small r. If the particle is inside, it just have to move itself out, right? So it's dx, this is dy. So we have dy dx so it actually should just be obstacle x plus dx, right? And then times by the distance, the distance required for non-collision divided by the current distance. Yep. Initialization of MinDis2 skip by the case label. Two 21. So I cannot do that. 221. Min distance to skip by the case label. But we didn't use min dist2 outside of the case. Oh, whatever. I can just bring it back, I guess. That's really not the point right now. Now we forcefully change the particle position, but that would probably definitely cause some problems, right? Nope. Well, I mean, so far it kind of works. I mean, yeah, that worked quite well actually. This worked very well. Oh, okay. Okay, we're cooking. We are cooking with gas now. Whoa, whoa, whoa. The performance is atrocious. But I mean, performance problem in Pixel Composer, that's big news. Cool. Now if we force the particle outside of the domain, will it still crash? No, it's fine. Now the collider is actually act like collider for once. Okay. That's cool. Really cool. But if we animate this, okay, now it's kind of weird, right? The the fluid doesn't flow down, right? The fluid doesn't flow outside of the particle of the obstacle because it just stuck there. It doesn't have the horizontal force to push it out of the circle. There's only have horizontal gravity acting toward it, and it just stuck there. So we can also add velocity to it too. Not just the position here. The velocity is just based on well, I'll say based on the tangent of the particle, right? So let's see. We have circle like what? Let me move this up here. There we go. So we have circle, but or shift view. Okay. Wow, that's a sharp circle. Circle, that's the obstacle. And then we have particles. Smaller one here. Now, at this frame, we detect that the particle collide with the obstacle, so it's just gonna move. First thing first, it's just gonna move. Draw a line here. Just gonna move it out to a new place where it's outside of the collider. That's normal, to be expected, but we also have to apply velocity. Velocity based on the tangent here. Based on the tangent here, right? Tangent here, and then apply this velocity to push the particle out of the collider. Oh, I mean, but that's really simple, right? Because we already know the x dy, right? I mean, this is just dx, right? This is dy, and this is dx, and this line is 90 degrees, so it would just be dy and negative dx, or dx and negative dy. So the problem is also the axis, right? Because when you calculate this, the y-axis actually go this way, so that's really gonna make things confusing. So like dx here would be negative value, dx is the object x minus obstacle x, so it would be negative values. dy here would be positive. And here we can just check because there's two sides, right? In this case, you just check, well, dy here is now, the vector has to look like this. So the dy here is negative, right? The x has to go down, so the x here is positive. So it's both negative dx, negative dy then. And if the circle is on this side, it have to go this way. Here the dy is also positive. The dx is now positive. Here become the new dx. The one is dy is a positive. Alright. And if it be dx would be the one to go down. The value itself is go down, value itself has to be negative. Right. So only have to invert dx. Hello, purchased Visual Composer recently. I'm loving it, but I would like to know if it's possible to animate the character by Silhouette. I thought Silhouette in the program takes the character based on the first painted frames. I don't think it is. I don't think it's possible, right? If you're gonna have animating silhouette, and only color in the first frame. I don't think it's a way to do that. At least the way to do that nicely too. Sorry about that. Yeah. Anyway, so what we have to do, now is we already got the dx dy, right? So we only have to check if particle position x is less than obstacle x we're gonna do that suggestion is close but not quite. The velocity x, we have to modify the velocity x by the inverse of the delta y, so inverse of dy, and then particle, the hell, particle velocity. Oh my god, okay, this is like when ChatGPT just not kind of working against you now. We change the velocity y, right? The velocity y now have to be invert the velocity x, so it's just negative dx. You might have to adjust the magnitude of this change later, but it also only happens if particle position y is higher than obstacle y, because if it's lower, which means, wait, y-axis go down, not up. Oh no, right? Y-axis go down. Yeah, y-axis go down. That's the problem. So if the stop it, Jesus Christ, the particle position, the particle y position need to be less than the obstacle position, right? That's the case. You change the particle position. You check if the particle position x less than x or not. Then you do that. Oh, wait. That's the velocity. If not, then you do dy minus dx. Now, wait, the y-axis goes down, right? So the y-axis increase as you go down. So this one minus this one has to be negative. Dx dy is negative by default. Dy is negative by default, so this one doesn't have to do it. So this one doesn't have negative, this one have negative, and the dx here would be the dx here is negative. You go down, dx here have to be positive, so negative dx. Okay, that should be correct. Do some sanity check if position. Okay, actually this is just dy, right? We could say if dy, which is the particle y minus the obstacle y, and we want the dy to be less than 0, which means dy less than, or the particle y less than obstacle y, or particle y is above. That's kind of confusing. Let's sure if dy is less than 0 and obstacle position, so less than obstacle x, so like, and dx less than 0, then you say you move to the left, move to the left, dy less than 0. Yes, oh yes, this means move to the left, right? And this is move to the right. And then you move down, which means increase dy, which means negative dx because dx is negative. Okay. Actually no, plus equal. We're not setting it. Oh, I should save that file, huh? Hi, Pixel Composer is an amazing program. Thank you very much. You develop it all alone? Yes, I mean, wouldn't be fair to say I develop it alone. I have a lot of help from, you know, different libraries and inspiration anywhere. But yeah, coding wise, all of this code, most of this code I type it alone. Didn't have like a coworker or stuff like that. But there are a lot of code that, you know, written by other people, some library that I use, some extension that I use as well. So yeah, it's kind of alone if you want to take it like that, but you can just check the credit, right? Like Makham Dev is me, right? Just me alone. But if you can check credit, you're gonna see that there are a lot of people working on, well, I mean, not working on, helping me. It's a part of the software. So we can add the collider here, move. Animate this, move it. Hey, it works now. Cool. Now we have the collider that actually act like a collider. Now, the problem here is that it looks a little bit too unrealistic, right? The water just got launched out of the particle, out of the collider a little bit too much, a little bit too fast. So we need to modulate this value. Let's just say 0.25. It could just be a constant values, or it could be a controllable parameters. But let's see if just constant is enough. Just save this, flip collide. What's the language you program Pixel Composer? Well, mainly it's GML. It's GameMaker language, right? Pixel Composer is made using GameMaker, and GameMaker has their own language, which, to be fair, is like really easy to understand language. I think similar to like JavaScript syntax wise, but it's its own language called GML. And there are some extensions that I use that written in C, like this fluid simulation. The main core, the fluid simulation are all written in C because it's way faster, right? GML is not known for being fast, so for more intensive part of the software, I use C. So let's check. Now, yeah, we have the collider, and it okay. That works. That's great. That's really great. Cool. Now, the second thing is we have different shapes, right? If it's a rectangle, you will still have the same problems. So let's fix that with rectangle. Where is it? Collision here. The first thing is to move the object out of a rectangle. This one shouldn't be difficult. Here we say if the object is inside in the range of if the absolute value of the dx, so delta x delta y, is less than the width and height of the rectangle, this means it's collided. Calculate dx dy. If the x higher than dy, so the absolute of the x minus ow, absolute dy minus oh, and we just set it in one axis. Is the x less than cy? Is the x higher than y? Wait, what is this? I'm not sure what I'm doing now. Well, if it's a collider, then we don't have to worry about this then. If it's a collider and you say obstacle is the obstacle is this, we just have to check we check the x, we check the y, and check which of the edges have the lowest absolute values, and we just move it out of the way. We don't need this at all. Well, we kind of need this, but let's say if absolute dx, okay, let me move back to the oops, point here. The dx dy is okay, so the dx dy is compared to the center of the obstacle, right? So we have again dx dy. So to check for collision, we can do the same thing. This part is fine. Then we check if okay. What are they trying to say here? Can you the xy here, if you check if dx less than if, should it be absolute though? Oh my god, can you say we want to know the distance from the edge, right? So we say distance from the edge in the x side would equal the width minus absolute dx, okay, and then that's going to be the distance to the edge, ex ey. Then we check if dx higher than 0. Well, I mean, first check if absolute, check if it left or right, right? So if absolute, nope, it's always positive. So if ex less than ey, so it's closer to the x edges now. Say if the x less than 0, then we say, let's see, particle position at x would equal obstacle x minus OW. That's not right. Particle position this would not be equal to this. Well, it would be equal to the x minus OW, but then minus r, which is the radius of the particle itself. Then the position at y would be the same. Then the particle velocity as I2 would equal particle velocity domain void elasticity. Now you're just making shit up. Nah. Now you're just making things up now. So the particle velocity at I2 has to be changed. That is true. It should be changed by, well, first would be the obstacle x velocity. Just that for now, right? Else, so have to do the same thing, but we do plus instead of minus, and x velocity, that's the same. Now you should cool dy less than 0. Oh, if dy less than 0, so again the y-axis is inverted, right? So if dy less than 0, the point is higher. So if the point is higher, you minus obstacle is OH minus R, and then inhibit the velocity. Okay, let's see. Save. And yeah, okay, it seems to be correct. Collide with the rectangle properly. Yep. Oh, cool. Very small. Very nice. If I just... Okay. Rectangle with rotation. Oh boy. Rectangle with rotation is different beats altogether, because it's simply just a triangle, right? A polygon. And if I'm gonna implement that, then we need to be able to support basically any arbitrary polygon shape. And that might be a little bit too complicated for now. Let's just have circle and rectangle. So let's say click add collider, improve collision physics.